everybody. Once again, good morning, afternoon, day, and night. This video is geared towards Standard 6B in Algebra 2, Semester 2. And so with this particular standard, we really wanted to focus on being able to write the equation that model the transformation of a graph or a situation. And so most of the focus that we have has been really around the graphs, as well as we've been talking about some of the stretches that exist for us. So I want to go through a couple that I kind of notice as major players for us, and then be able to send you on your way for your practice and what have you. So problem number one, what you see is that we have a graph that goes from 0 to 5. And one of the elements that we need to talk about is if the graph is odd and if it's even. And so question number one asks us to show that if this is an even graph, how the graphs will respond. And at the end of the day, what ends up happening is even when we put a negative in for the x or try to flip it, we end up retaining the same y value. So since we see this graph going upward on the right-hand side, those same y values are going to show themselves up on the other side. So it's going to be kind of like a mirror, or like you open and close a book, or if you have a butterfly wings. So just to kind of give us some points here, at -1 is going to be the same y value as if it was at +1. 2, the same thing, a little bit up. 3, a little bit higher, and then 4, a little bit higher than that. So we should be going in a similar direction. Now, since we're kind of making a sketch here, just kind of do the best that you are able to do. For the next problem is saying if it's odd. And so what this is saying more than anything is that if it's an odd function, what ends up happening is kind of both scenario changes, or they both end up switching at the same time. So it's not necessarily so much a reflection or a fold as much as it's more kind of somewhat of a rotation if you kind of go back to geometry. So for that one, it's going to look similar to what you saw me draw in the pink ink. Because as you change the x value from a positive to a negative, then those y values end up also changing their signs as well. This is an odd type of function. So the colors you see for 1 and 2 kind of mirrors if it's an odd or even function. So problem number 2 asks us to classify if this type of graph is odd, even, or neither. Now, once again, we just talked about how if it's odd, that as you put in negative for x, the function or the total ends up being negative at the very end. If it's even if you end up putting a negative number in, you end up getting the same answer as you had before. Neither means it's all jacked up at the end of the day. So for this one, if we think about it, how does it fold over? We're actually going to want to select that this graph is even. Because if we kind of look at the y-axis as that line of demarcation, or the line of symmetry, if you want to use that term, if we fold it along the y-axis, then these graphs would match up or mirror each other at the end of the day. So for this problem, it is even. Okay, let's go to our last one. So last problem we have, and this is, I think, everyone's favorite, it has to deal with scaling. So we have this graph. It says we have function f, which is the darker graph that you see here. And we have the function g, which is the dotted graph that you see here as well. For each, we are determining the value of k so that g of x is equal to f of k of x. So real quick, just kind of a recap from 6a. This function here is a g of x function written in terms of f of x. Now the key that this is helping us and giving us is that k is inside with the x. So even though this is scaling, or you may also hear it as stretching and shrinking, or stretching and compressing, because the k is inside, this is happening horizontally, meaning the x values are the items that are changing, the y values are remaining the same. And so no other place can we see that then if we actually look at the graph and we find the points of 3.1250 and we look at the point 50, there's a change that happened to get us from 3.1250 to 50. Now, to actually find out what that K value is, we're going to take where we are at and divide that by where we're trying to go. Make sure I say this correctly. Nope, I'm going to flip it, which is okay. Let me double check. Now I'm thinking like y'all are. Nope, I'm gonna stick to my guns here. Take where I'm at and go to where I'm going. I'm gonna do it that way. So with that being the case, I would have 3.125 over 5. And if I take the time to actually do that calculation, it will give me a decimal, if you will. More importantly, what I need to know is if that's my scale factor, that value or fraction or decimal, if you do the division, ends up in the K spot. So my final answer is going to be that g of x is equal to f parentheses 3.125 divided by 5 times x. That is the function that will allow me to be able to talk about this dotted line that we're talking about. So remember, if the K is inside like this, it's stretching horizontally. Now, which number tells you if it's stretching or compressing? If that number is outside, so kind of going off the grid a little bit, if that is g of x is equal to, let's say 3.125 times over 5 times f of x, this is scaling or stretching vertically. And depending on how it's written will tell you if it's stretching or compressing. So it's one thing to definitely know the factor. It is another thing to be able to talk about the position. Position tells us if it's vertically or horizontal, but the number and finding scaling is done by a fraction. At this time, I'm going to release you to go be great, and until next time.